Here you form
Of course, Harry's.
doublets for the column, which was popular, it was aluminum. Now it's here's a die for the wing rib, which is different now. So you got different dies, Kempep has them.
Our break even now, we got our break even now, 600
You know, right here you're punching a big prod, big parts over there. They all set up for punch presses.
Aviation. We did the Mitsubishi, when we brought the Mitsubishi plant over the beach part, we did that whole plant, started to lay out production. And he's willing to work on this project, either on some kind of basic or.
Yeah.
Now, we got two sets of bonding fixtures for the four-pack. One set is here and one set is ten-pack. Well, they got this too. They got the detailed part.
By the way, there's an old outboard wing frame. Yeah. By the way, gentlemen, here's the draw die for the metal A5.
If in the event
How?
you're going to be making this,
Right there.
you need to stay with them.
The big thing there? Draw the metal cowl. Because we're not using it because we went to composite, graphite. Yeah. And there's some master models for the winglet fairings. Here's a master model for the, you know what that is?
Mm-hmm.
But these, the wheel covers?
Those are the spats that go up around the landing gear.
Oh.
Here's a
Upper
master
spats.
model for the carry-through spar.
Oh, yeah, I remember them making that. I saw that in the plant over here.
No, we didn't bend it here, we drilled it here.
Well, I saw it in the thing.
Yeah, I'll show you the drill fixture. That unit probably cost you $30,000 today. I experimented with molds that would make the out of fiberglass.
What is this, some experimenting that you did on composite? Or?
This is part of the tooling that we built a composite layer mold.
Well, that's
I'll
those
show you the
things.
molds in a minute.
No, I'm
By the
not-
way, here's a dorsal fin rotor fixture. That's a dorsal fin rotor fixture, the trim.
That's the one I was thinking you were talking about.
Right. You put it in here and, you pre-drill. No, I take it back. We got, oh yeah, we have a drill bar on the outside to pre-drill.
Sorry, sir. If you go to M&E, first off, you got to have a tree. About a tree.
Now, that's a master model for the
FAA before
canopy
you get
area.
the thing certified.
That's a master model
In
for
the
the
US,
car.
if it's built over.
And of that one, we made splashes to
I don't know if they have tree in there.
Second is the 30%.
which are sitting,
value.
where?
Already 30%.
Over there someplace.
What I would do
Here we got lab
is
molds.
build all the detailed parts,
We made our own,
Okay.
all composite parts we made in-house.
ship those by containers in
Lab
the
molds,
US.
right there for the winter.
And you
one
can go
is-
subassemblies of them.
Grumman, and one we built here because Grumman did not send us all the tools.
then
But they're complete now. Here's a bond fixture. Here's a bond fixture for the wing fairings. See, the individual parts have been laid up right here
I was talking about just
in those molds, layer molds. Then they went into the bond fixture, which used to be
basic parts.
had a different purpose, but I modified. We made a bond fixture out of it. So it's always alike when it comes out in size and shape.
When I say subassemblies.
There are two different sections. Here's a layer mold for the lower cowl.
Yeah, that may be.
14 different parts that are stamped out.
This is all it
Yeah,
is.
to make that.
Oh, here's one of those modifications you did to the,
That's correct, yeah.
That's probably all.
I don't know what that is.
You're pretty well informed. I was working here on, for example, on
Then later on,
modify the trim line and get those parts pre-drilled. You need to save money on the time on the final assembly line. The parts got to be built up to the high state of completion to the engineering drawing. Sometimes you cannot put holes in because you have to match it to something else.
Yeah.
But theoretically, they all could be pre-drilled and matched, theoretically. But in most cases, they are. Here's a layer mold for the A1.
What's your opinion of the composite cowling as opposed to the old style? Was it an improvement?
It's up to the beholder. David Fletcher likes the old metal cowl. Many other people nowadays want the composite cowl. It should be really in fast. We use the graphite, which is too expensive.
But it made it easier. You didn't have to take the prop out to get into it. I understand that. But does it make it go faster, or
No,
what's
I
the
don't think
advantage?
so. I don't think so.
Can you make it cheaper in metal or in?
Probably not. I was asked to have vendors quote to restart the metal tooling, and some of we had and some we didn't, and it was more expensive. At least what we did here. See, I found a tool maker in my crew in the composite department. He was laying up on some junk tooling that a vendor made outside, and we paid him $10 an hour, and he built all the tools. We both built the tools.
Yeah.
So you got layer molds. You have actually secondary master models there. You can build additional molds just like that.
Yeah.
They're there.
Yeah, I need a chair like this one. That's nicer than what I've got.
There's a bond fixture for the wingtips. Kind of interesting. See, it's split and hinged right here. Again, this came off the master model, and when you get through with the wingtip, it will always be alike. They split right here. A simple operation. It opens up like a clamshell to get it out. Here the layer molds. Right, the layer molds. I'm thinking because we have an opposite, which is the master, to build that mold, you know.
Yeah, it was interesting. We had an AG5B in for annual in September, and I had to had the wingtips off of it, and we also had a 78 in there at the same time. And I just happened to pick up. I was doing some comparison on something. I picked up one and picked up the other one. That AG5B wingtip weighed less than half of what the
Exactly.
A5B did.
Oh, I know that. Because you know who built the fiberglass parts for Gulfstream? It was a fiberglass tank company.
Yeah. Oh.
They make their tanks that thick, you know, and nobody complained. So they're heavy. Those are light. Right here.
Yeah.
Well, you know.
Yeah. It's the skin.
Just
you
half
know,
of
it's
it.
yeah. You squeegee the resin out and.
And here's
Take
the
it
polyester base coat, gel coat. And then you sand it off and paint it again with a urethane paint. And it works a lot better than the black gel coat, which was not polyester, because the resin is vinyl ester. Vinyl ester. Here is the lower cowl. still got a gel coat on,
Mhm.
stopped us right in the middle. And the upper cowl, later on we cut it apart. It's one piece. We got a rudder fixture to do that somewhere, to trim it exactly, and we have trim lines right in here to trim it to the trim lines. And as I mentioned, it's a little bit extra, maybe 60,000. So the final trimming is done and fitting is done on the final assembly line as you assemble all the parts. Here are the two final assembly fixtures that I designed and built with a bad bag in Cleveland. That's for the Traveler. See, it routes all the cutouts, it drills all the attach holes for the lower cowl. And this one is, wait a minute.
This is the Traveler here.
This is the Traveler.
Yep. It's Traveler. This one, this is the AG5B because you got your
That's right.
air inlet.
You can't start forgetting. Yeah, it's modified for the AG5B. The engine cutout is in a slightly different position, and the lower air exhaust in a slightly different position, but the size is the same. You could put a metal box down there if you like.
Yeah, we've found by refabricating that metal, just virtually copying what Grumman had when some of the metal ones they put in, other than the fiberglass lower ducts, that put a roll leading edge on it back and raise the height of it 3/4 of an inch. We're dropping cylinder head temperature some 40 degrees.
No kidding. Well, that could be incorporated, you know. The cutout
Yeah, that's a mod we've been doing
will
for
probably
years.
stay in place. And it's slightly different by, it's more inboard, the cutouts, compared to the B or 5A. Here's a bond fixture for the outboard wing frame. It's a mechanical bond fixture with mechanical pressure. It's here because the better one is in Hot Springs. It's a bond fixture for the upper cowl, metal cowl, which of course is replaced by the composite cowl now. It's a bond fixture for an elevator. And of course you have bond fixtures for the wing. They will bond an A1 or an A5. An inboard, I mean a short range or long range. I would forget about the short range wing, period.
Yeah, that's history. It's been my understanding that the original Yankee bond fixture, you know, the
That's
Yankee
it. It
airfoil
started
bond
off right
fixture,
there.
has been
frame.
modified.
Yeah, the bond shoes.
Yeah. Do you still have the Yankee bond
We
shoes?
have the bond shoes here someplace. It might be. It might be over there someplace. I know we have the bond shoes. They are in a not in a very good shape, but you could redo them again. Refurbish.
Yankee wings are about as rare as chicken lips to get your hands on. We just hoard any of them and repair any of them we can get our hands on.
Oh, I see.
The bond fixture will work for the two-place or the four-place.
You don't have a Yankee wing bond fixture too.
We have. It started off with those frames, and I got the bond shoes for the Yankee someplace down there. They need to be refurbished. I think one set of bond shoes. Here's a framing fixture for one of the elevator or rudder, possibly. The frame is honeycomb ribs and a tubular frame. It's bonded together, assembled, adhesive, paste adhesive injected, shoved into the oven. Then goes the skin on in a separate operation in a fixture like this. The frame is located by this shaft, and the pressure applied to the skin by air pressure.
Yeah.
See silicone air hoses? Doublers have been put on the inboard wing the original Yankee spar. Doublers have been put on, 2 of them, to reinforce the inboard A5 wing. That's the fixture that mounts the doublers on, air pressure too. Another one is in hot springs.
What's this round tube like thing?
That's what he's talking
Oh,
about.
that's what you're talking about, the doubler on.
Yeah, it's a quarter inch or 332 honeycomb core with an overlap, right?
No, it's
the
just
quarter.
plain aluminum sheet formed with the joggle in place because it overlaps the expansion, the joggle, the expansion expanded and on one end. So they're located there, they're taped in place with adhesive tape, and then the pressure is applied by air. See the ends? I came up with that expander. You turn it and you expand the end, make it round during the bond cycle.
Yeah.
Because it's not perfectly round when it gets to that point. Or to keep it round, let's say that, to keep it round. Here we have a rudder bond fixture for the A5 series, starting with the Traveler all the way to the Tiger, they're all the same.
That's right.
And there's a bond fixture for the AA5 elevator. Guess what problems we had. See this right here? We call it a heat shield. We built a fixture, it didn't have those heat shields on. The skin is only 16,000ths of an inch. When it came out of the oven, the 16,000 expands more than the spar. And we had oil cans, I mean real oil cans. So the lead man in our tool shop at the time says, why don't we keep the hot air off for a while so it gets there later. Design those heat shields and it worked like a charm. Without those, see,
Like potato chip.
that's the beauty about the bonding. It's not like a Harry Eckhart. You got to have some other knowledge to make it work. And if it doesn't work, well, make it work. Here's the fixture we built in Cleveland for the horizontal stabilizer. You assemble all the parts, all at one time.
Oh, yeah.
In that fixture, and you have a horizontal stabilizer, about 12 feet long.
That's quite a jig there.
Yeah, I helped to build that one too. Oh, here's the windshield bond fixture right here. For the present, for the A5 series, period. They're all alike.
Yeah.
And you locate against stops the glass, and you apply bond pressure again by silicone air hoses right here. The connection for air is right here. And when you get through, it comes out, and I mentioned that yesterday, and the bonded windshield I had this built by my master carpenter. The bonded windshield goes in here. The glass, the windshield bow is here. It's supported right here. And the glass sticks out now as much, it's uneven. Maybe that much, maybe that much.
Oh, and you cut it off. Right?
Here's a rudder fixture
Yeah.
with a spring loaded because of the different contour. It's upside down now.
Yeah.
You got guides against the bow right here, and you rod it off. You go over it slowly and you go back, it will take off a little bit more, and you have a nice smooth surface for the canopy and windshield seal to match perfectly. Grumman did it by hand, we did it by hand for a while, till I came up with this in '93. Here's the nose landing gear.
That's the machine we were talking about.
Right here. It is operational. We made it operational. It was not operational when it came from Gulfstream. They cannibalized those switches. We had to buy and put them in. Here was a kind of a first try. See, the tube has to be machined on the outside. before you do the bending. And but we went out of business. Dennis Hunter had his own fixture to bend this, and it was not exactly to fit the gauge. It was acceptable. Here's the hydraulic unit to power this. It was designed by Gulfstream. Excellent job. No fun, we used it in Savannah. Here's a balancing fixture to balance the control surfaces. Put the lead weights on.
Yeah.
Here's another bond fixture for the four-place aircraft. One is in hot springs. They got two bond fixtures for the lower. Two places. Now this unit right here took a long time to make that work, and the expander.
For the spar,
Expand each spar. We use urethane, precisely machined plugs, and by experimentation I came up with the final numbers for the diameters and the length. See, it goes, the urethane sleeve is in here. It's now covered up, it's inside. You have two half shells which create the actual joggle. And what the hydraulic unit does, as much as 4,000 psi, it pulls the piston back. The spar is already inside against the end stop, right here. It pulls the rubber back and expands it against a removable outside diameter shell, because we get different diameters. We probably have all the shells in there. Now, this is set up right now, well, not set up for anything, but here's a center located for the carry-through spar. Here's a drill fix for the carry-through spar. For all carry-through spars, except I took off the A1. No, I covered them up. The A1 is here, the attached wing lock holes. The A5 is here. So the tool, it starts off with all the tooling holes. You locate the spar. You locate the spar. Gee, I forgot how to locate the spar, but I'll figure it out. Anyway, you drill the tooling holes. Then it goes into the, well, you drill only the tooling holes, period. Then it goes into the cutoff fixture, which locates every spar, including a carry-through spar, and both units come in and cut off to a predetermined length, to a final length, guided on those tooling holes. The tooling hole pin is not, you can't see it from here, but it's right in the middle. Then it goes back into this fixture, and you drill all the attach holes. They're all the same for all aircraft, except the two places here and four places here. This fixture probably, it was reworked so many times, see right here, by the tool shop, that it probably cost several $100,000 in cost. It works now. We start off with wing spots, for example. I built this fixture here. Put it on rollers. A height gauge is put on, located here on the steel. And you find the high spot, the bend. They're not straight. They cannot make them straight. They do it with our tolerance. It may be 100,000 off, but mostly maybe 60,000. Little bend. You find the high spot in market. Why? Because in the bond fixture for the wing, there's only room inside of the rib cutouts to put the bend this way, not this way. So you have to find the high spot and mark it. Well, it's marked by serial number. We put a serial number at a certain location, which is shown on the drawing. Then the bond operator knows where to put the spar. See, all of this you got to know. So you got to send your people over there and learn this in Hot Springs. I can help them. Before drilling the carry-through spar, it's being expended here. Again on the tooling holes. Everything locates of those center tooling holes, which are shown on the engineering drawing. After expansion, on each end, this is a so-called bumper I talked to you about yesterday. A simple unit. It's not round. The expanded end is not round. The spar is not round when it comes from Alcoa. They cannot make it perfectly round. It may be off 60,000. After expansion, you would think it would become round. No. It follows the original trend.
Oh, really?
So we find a high spot with gauges, with micrometers. They're specially made for that purpose. We got them. And bump the high spot. Again, the operator got to know what he's doing to come up within the tolerance level, which may be as much off as 20, 30,000. I'm trying to recall the numbers, but it's very little. And of course, then you take the spar, the inboard spar, and load the. From then on, it goes into the aircraft. Here's the assembly fixture, the final assembly fixture.
This is what you put a fuselage in?
The whole fuselage locates on its aft end, and then you locate this jig and drill the attach holes for the horizontal stabilizer, which side in a vertical angle bonded to that particular area. You locate the fuselage by measuring from the engine mount hole. So you have the same measurement on both sides. The fuselage may vary 30,000, 40,000. So you split the difference. And then you lock it in with shims against the side right here.
Yeah.
So it doesn't move. And we got some wedge shims someplace. And make sure that the fuselage is not twisted by looking. See, it's supposed to be lying flat here, there, period.
Can you make adjustments if it is a little off? Can you adjust it?
It wasn't off,
You never had one?
not my knowledge.
Uh,
Within tolerance. Again, you have tolerances on the engineering drawing. They are normally 30,000ths of an inch.
okay.
Yeah, well, it may have been off that much,
Yeah.
but within tolerance. Well, if you like to get the twist out, which you really shouldn't, you can step inside and it will straighten itself out. But you
Okay.
should not do that. A little twist will not hurt, because all the attach holes, the carry-through spots located here and there, and the attach holes for the engine mount, even if you have a little twist, assuming you have one, the engine mount and the engine will be in the right place,
Yeah.
and the spar and the wing will be in the right place. Who cares, theoretically, if the fuselage is slightly twisted?
Yeah.
But the important parts are located by tooling holes, pre-drilled holes properly. That's the horizontal stabilizer, the vertical stabilizer, the wing, and the engine. So,
You can put a sport screw in between, huh? The fuselage can be any shape as long as those 3-4 things.
in theory,
Yes.
and we used to have a simple $7 thermostat in the back to sense the heat and had to turn it on and off within 10 degree allowed and the operator working on it could do it within 5 degrees.
The only thing is.
Anyway, they wanted a computer put on. I said, forget about it because it worked. No, they ripped it apart, and but we have bond fixture, a mechanical bond fixture that goes into the oven at ChemFab for the inboard wing. But this fixture was so efficient in Cleveland and Savannah that the best operator, girls, could load that fixture and bond 2 spars in 1 hour. The most operators have not been as efficient. There was Dorothy. They ran maybe 5 sets of spars in 8 hours. Not spars, frames in 8 hours. Now the other fixture, which is mechanical, it goes into the oven. That's what ChemFab wanted. So this one is not operational right now. We have to connect the cartridge heater, and we have to get some kind of a thermostat on, maybe connect to a computer, which we bought. It was $5,000. Never used. But the other fixture works just fine. Here we have tooling. All those tools right here and right there are from Advanced Engineering. They used to make our Tiger parts. All of those. Right there.
Lots of stuff here, for sure.
I would replace this monster with something simple. The cutoff for the well, for every spar with a saw, a carbide tip saw, which could be a lot simpler. It's an old design. This fixture you can set up and start an operation in 2 days, because it has to be shut in and leveled with a transit and periodically checked also.
This is the only fixture on the whole assembly line. This is station 13.
Right.
And this is where you put the fuselage in with the turtleback on it, and you align all of your telemetry, I guess, for your horizontal and for your wings and for your engine, and everything is done in this station. Once it leaves this fixture, there's no more fixtures on the whole assembly line.
That's right. The only one. You locate the Achilles spar, which is bent with all the holes straight road, all those tooling pins. We would drill the attach holes for the horizontal stabilizer forward, attach holes for the stabilizer bolts in, and you drill the engine mount holes, and with one long drill all the way through, from top to bottom. And we just discussed, even if the fuselage theoretically is twisted, which it is not, it's within 30,000. The engine, the wings, stabilizer, vertical and horizontal are all in relation to each other correct. The flies level. This a fixture.
So if it doesn't pass here, it can pass
If it
at
doesn't
all.
pass there, it doesn't pass, right? That's where you reject.
So that's the like the final stage.
No, this is the first stage,
What is the primary stage?
primary stage.
After this, then you set it on its wheels, then.
No, after this, it goes to wooden, like stands like
Oh,
saw
yeah,
horses.
yeah, I remember seeing
And the
that.
wheels go on about 3 stations on down the
Yeah.
line.
You put the fuselage on its side, so the people can work this way, standing up, and attach additional items, to the inside of the fuselage. And all those extra bond fixtures, like I said, they will bond the A5 series or the A1 series. And with some modification, you could bond the original A1, Yankee also. And we have those bond shoes someplace back there. They need to be
All
refurbished.
these tools were ready when we made parts on them.
The ChemFab is doing now the steel firewall now, up and lower. Much better job than Dennis Hunter did. Most of the items he did have been okay. And that expander, by the way, there's only one, expands all the spars, starting with the Yankee all the way to the 5B. That was the beauty of the design of the aircraft. When it was started off as a two-place aircraft and then became a four-place, all engineering did, you used as many parts as possible from the two-place on the four-place. Even the wings, you just added another panel to it, they shoved it on, put pins through, you know. This is a so-called turtleback fixture for the, for the aft upper fuselage for the four-place. There's another one in the back someplace for the two-place.
Yeah.
That's for the four-place, the second fixture. See, we had to build duplicate tooling in Savannah when we probably averaged 60 aircraft a month. When they shut down, shortly before they shut down, they broke a record, 88 aircraft in a month. We have been in Cleveland even more efficient with about 250 people. The best we did have aircraft in a month. 250 people, that's all employees. Now we have some drill fixtures for the locating fixtures for the torque tubes, aileron torque tubes. By the way, those yellow fixtures are the fixtures I pointed out drill the attach holes on the wingtip.
Yep.
On all wingtips. All tools have been, if possible, modified to work for the two-place and the four-place. Well, this one was modified by adding. See, the two-place fuselage looks like this. It terminates here.
Oh, yeah.
So the tools are added to this portion and moved the carry-through spar and some other locators. It became a four-place fixture. So what engineering, the beauty is, see, from here on, theoretically, it's all the same as a two-place.
Yeah.
What they did, they added to the front. It's just absolutely fascinating how they economized to design a four-place and use two-place parts. Oh, now I know where to get my wing lock holes from. I didn't remember in the carry-through spar. This is the first step right there. This is the leveling. You level that fixture.
Yeah.
You locate the spar with a. We use an electronic inclinometer to measure degree. See, when the spar is being bent by the vendor, it's supposed to be 5 degrees, plus minus half a degree. Can you imagine half a degree?
Half a degree.
But it's slightly off. This side overemphasized. Looks like this, and the other side maybe like that. So what that fixture does, it does this trick.
Oh, I see.
We measure and the same angle on both wings.
Yeah.
Then we drill that tooling hole. From then on, I explained before what happened. Here we get some new tooling for the wingtip. Some sharp aids. But like I said, we've been in full production on all composite parts, including now a composite graphite dorsal fin. Here the drill fixture that I mentioned for the landing light, which is different than the original one, different part number. Anytime you change something on an aircraft, you have to create a new part number. Even if that sucker has 2 different holes in a different location. Sometimes, not all the time. Door fixture for the position light. It's used both, come to think of now, for the lens and the wingtip. Guess what? They will match.
Yeah.
You see, that's a problem of the Gulfstream or Grumman built aircraft. Was you never find 2 wingtips identical. And that's the reason we don't pre-drill the holes in the nav light lenses that we make.
Yeah.
We were the vendor to them on those Navlite lenses from serial number 143 up through serial number, or 43 up through serial number 50.
Cardboard box
150 something.
has templates and some paperwork from Dennis Hunter, Advanced Engineering. Oh, here's a bond fixture for second bond fixture for the canopy. That's another beauty. Oh, I help to help the people of Roar in Riverside, California, to design it, fix and build it. Build a second set. See, they built some of the better bond fixtures, the second set of bond fixtures. What the fixture does, it locates all the parts, relative to each other by tooling holes, applies bond pressure. The cage can be taken off later on or before. We put a hinge on here and applies bond pressure again around 15-25 pounds. And you have a canopy in one shot. You can load it in half an hour. Here's an assembly fixture for the canopy.
Do you know that plane, the beach craft?
I built this one too, so people can stand on the inside and work. You locate the canopy by tooling holes, which are in the bow. They start off in the bows, forward and aft bow. Then you locate the outside retainer.
Is that a mentor, right?
And
Yes, mentor. It's a tandem seat Bonanza.
Oh, it's a Bonanza.
It's a Bonanza fuselage and it's a Bonanza airframe. It's just tandem seat military configuration. Same wing, same landing gear, same engine, same tail. Use the standard 3-piece tail rather than the V-tail. Same tail was on the A-36.
The canopy also frees. Back,
Bond
center,
fixtures for
and
doublers
No, two plates.
two seats.
It's two seats.
Yeah, two seats.
The canopy's actually, you got a center section. You got a front canopy and a rear canopy, and then the rear window and
Which one of the aircraft here is compatible with?
none.
None.
That's a retractable gear,
Oh, yeah.
complex aircraft.
300 horsepower.
So that's
It also is a $500,000 price tag.
Some places they stamp how many pounds or foot, whatever. Same thing with the other.
Base price.
Maybe the knowledge. It even locates the fuel cap that provides bond pressure to the skin before it goes in the wing skin bond fixture. We call it the skinning fixture. Framing takes it to the frame, skinning fixture with the skin. Now here we have wiring tables that have been built here specifically for the AG5B. The wiring, locator and assembly.
All the panels basically the same? Or the back panel was probably all cut out the same, maybe the front was different.
Yeah, well, they changed instrument panels 2 or 3 times on the AG5B, and then they're different yet from what was in the AA5 series.
Oh.
And there's still room for improvement.
You will notice a tooling tag someplace. You can see it had to be approved by the Quality Control Department as being correct, FAA regulation.
Harry was talking last night that Colin was just bringing up about the panel. Essentially, they custom configured the instrument panels for whatever was going in that particular aircraft.
That's right.
Rather than having a generic panel that you just plugged and filled holes.
It was generic only in respect of the having the major instruments,
The normal
compass
thing.
and so forth. And then it was up to the customer to, whatever he orders on avionics, to be manually cut by the machine shop here.
There's probably
That
this
is-
much tooling still at Campo.
Yep. Including they have all the dies for the ribs, the new ribs, the 40,000 rib thickness was redesigned to work without backup blocks on the inside. We have the old dies for the 25,000 thick ribs, which have been in operation till about 1974 or so, 75. But they need backup blocks on the inside to react against the outside bond pressure. So they redesigned it to make it more efficient during operation. And so there's no tooling to make the ribs. Kemper. We talked about yesterday.
Yep.
It took some time for them to figure that one out too, how to make the ribs. Yeah, here's the master model for the cowl. You could recreate the metal cowl if you like, if the tools are, not all the tools are here. I understand some are someplace in Wichita. But there's the master model, the original. Again, Camfab, you give them that one, they can recreate anything you want in metal.
Yeah.
That's your starting point. We did some vacuum forming of interior parts. We built those vacuum fixtures here. Those are relatively simple parts that we made here, and we had a vacuum form machine. What's so damn sad? We sold for $200,000. Master model for the master gauge windshield boat. The waiter had problems with shape, so I took that one off the master model, canopy master model right there, the shape, and then we bent one bow. No, we sent it to Chemfab, and they adjusted their tooling. They have been making the bow, and it worked just beautifully. All three good too. Here are drawer fixtures for the sump cover, by the way, which LI Plastic was doing for us, and all the all the interior was now made a little bit heavier because we had problems with thinning out in the corners. They had problems. Our quality control people didn't like it. So I said, oh, let's go to 75. Worked out fine. So practically from here on, the A1 and A5, and over there some of the Tiger Wild Tools would do everything.
Yeah.
And the drawer fixture for the wing spot there. Let's go, okay.